In today's quickfire questions, we're looking at IGCSE and GCSE Physics. We're looking at the maths element. So I found a load of miscellaneous questions. I'm going to get you to attempt them and then you're going to see if your answer matches mine. So question 1. An empty beaker with a mass of 50 grams was placed on a balance and 100 centimetres cubed of liquid was poured into a measuring cylinder. When all the liquid is poured onto the beaker, the balance reading changes to 140 grams. Calculate the density in the liquid. Just going to highlight the important bits here. So we know we've got a volume here and we have a change in mass. So here's a volume, we've got mass. Thank you. We have density. So DMV, drunk men vomit, here is the formula triangle we're going to be using, which states that density equals mass divided by volume. I do like to write what I'm doing here. Now, let's check out the mass carefully. So the empty beaker with a mass of 50 grams was placed on a measuring balance and then liquid was poured into it and the new balance reading was 140 grams. So hopefully you can see that the mass of the liquid must therefore be 140 grams minus 50 to get 90 grams. So our mass is 90. Our volume is 100. I'm okay with my units because the answer needs to be G per centimetres cubed. So 90 divided by 100 is 0.9. 2. Write down the equation which links work done, force and distance. Here's the formula triangle. Cover the value you're after. It doesn't really matter which way around you do it. I'm going to do it in terms of work done, so I can see that work done equals force times distance. 3. What energy is required to move an object if the force is 14.21 newtons and a distance moved is 2.3 meters? Sorry, that formatting is horrible. So let's highlight what we have. We have energy, we have force, and we have distance. I know this looks crazy, but I find this really helpful. Remember that energy is the same as work done because they both have the unit of a joule. So you can actually use the same formula triangle as above, and it looks like this. It's either WFD or EFD, it's the same thing. So we're looking for energy, so I can see that energy equals force times distance. Our force is 14.21 newtons, our distance is 2.3 meters. Pop that into the calculator and you get a value to 3 sig fig, which is 32.7. Careful with your units, it's in joules. 4. In a race, a cyclist travels 50 times around a 3.2 kilometre racetrack. It takes them 3.1 hours. What is the average speed of the cyclist? So, what do we have? We have a distance, we have a time, and we have speed. So this is the formula triangle I need this time. We're looking for speed, so I can see that that's distance divided by time. Distance is 3.2 kilometres times by the number of times it went round the track, which is 50, divided by the time, which is 3.1 hours. Pop that into your calculator, so 3.2 times 50 divided by 3.1, you get an answer which is 51.6 kilometres per hour. And that's again to 3 sig fig. I didn't change the units because they didn't ask for a particular unit in the question. 5. There were 4 beakers. Beaker A had an area of 10 centimetres squared, a depth of 6 centimetres. Beaker B has an area of 20 centimetres squared and a depth of 4 centimetres. Beaker C has an area of 30 centimetres squared and a depth of 3 centimetres. Beaker D has an area of 40 centimetres squared and a depth of 2 centimetres. Which beaker contains the largest volume? Okay, so let's just work out all the volumes. Remember, volume is area times depth effectively, so this will be 60 centimetres cubed. This is 80 centimetres cubed, 90 centimetres cubed, 80 centimetres cubed. So we can see that it's beaker C. Calculate the velocity of a bus travelling through town with a mass of 5,040 kilograms and a kinetic energy of blah blah blah. Let's identify what we have: velocity, mass and kinetic energy. So hopefully this is screaming KE equals half mv squared. We have our energy, so 493,900. We need to do half of mass, so half of 5,040 times v squared, because that's what we're after. Let's tidy up this sum by doing half of 5,040 first of all, to get 2,520 v squared. To get v squared by itself, divide both sides by 2,520. To get 195.992. And then you need to square root to get v by itself. And that gives you 14.0 meters per second. And be careful with your units, it's velocity, which is why this is the correct answer to 3 sig fig. 7. Calculate the velocity of a lift travelling up to the top floor of the Empire State Building with a mass of 4,200 kilograms and a kinetic energy of 4,116 joules. So velocity, kinetic energy and mass. So it's the same equation. Just make sure you substitute in all your values nice and accurately. Let's sort out the right hand side first of all. We need to divide by 2,100 on both sides to get v squared by itself. Square root. And your final answer is 1.4 meters per second. 8. A car travels from one town to a neighbouring town. The car reaches a top speed of 80 kilometers per hour, but its average speed between the two towns is only 70 kilometers per hour. The journey between the two towns takes 20 minutes. Calculate the distance between the towns. So we've got speed, we've got time, and we've got distance. So we need this equation. We're after distance, so we need to do speed times time. And actually the important information here is the average speed is 70, so we're going to use that number. We need to be careful with our units because that value was 70 kilometers per hour, but our time is in minutes, so I'm going to convert that time to hours by doing 20 divided by 60. So the final answer here is 23.3 kilometers away. Let's see if that makes sense. So it has an average speed of 70 kilometers per hour, but it only travels for 20 minutes. So it won't obviously have done 70 kilometers because it's only traveled for 20 minutes. So really it's only a third of a 70, which is your answer. And actually my answer is sensible because 23.3 does look like a third. I do like to check if my answer is sensible. How long would the journey take between the two towns if the car could maintain a constant speed of 80 kilometers per hour? So we're looking for a time value now. We've got the speed we're going to use, and we know the distance. So using the formula triangle, I can see I need to do time equals distance divided by speed. The distance was 23.3 kilometers. The speed was 80. So it would only take 0.2916 hours. I don't really like that, so I'm going to convert that to minutes by timesing by 60. So it would take 17.5 minutes. I'm sure it would have been fine to leave it in hours. I just don't think that looks very nice. The speed of a lorry was 80 kilometers per hour. What is its speed in meters per second? Okay, this is quite hard actually. So 80 kilometers per hour, you need to choose to change one of those units first of all, and then we'll sort out the other unit. So first of all, let's change that to in meters per hour. So you just need to times it by 1,000. So hopefully you can see that it would travel way more meters than it would kilometers in that time. And now we need to convert that to seconds. So in order to convert hours to seconds, you need to divide by 60 twice. The first divide by 60 takes it to minutes, the second takes it to seconds. So 80,000 divided by 60 twice is 22.2 meters per second. What is the equation for calculating acceleration? Well, acceleration equals final speed minus initial speed over time.